We kept on discussing on permutation group, and the target of permutations we discussed are some text. Do you still remember the question raised in the beginning of the class? Corresponding to this square for the corners, we used two colors to paint them. How many different solutions are there? If these images are placed over here still, corresponding to different positions, it will be colored differently. How many should be there? Accordingly, actually, what can be seen is some images. Why? They are images, just like a photo was placed over there. What are we saying is that it cannot be moved. So how many images are there? For each vertex, we have two choices. There are a total of 4 vertices, so it is 2 to the power of 4 different kinds of images. But what are we looking for? We're looking for construction. Construction is corresponding to a coloring solution, which means if through external force to perform the movement, for example, rotation and flipping, originally through a movement, it may produce another image. Then these two images we are equal. What are we asking for? How many are we asking for? Different equivalent classes. Then how many coloring solutions are there? First, after the rotation, its internal structure remains unchanged, whereas the so-called permutation, which is permutation, we are seeing 90 degree of rotation, 180 degree of rotation. It is considered a permutation. Through permutation, its image will change to another image. Then we are currently studying a group should be the permutation group. For example, we give all these images, 16 images are labeled with some symbols from 1 until 16. And this time, corresponding to some external operations, for example, 90 degree of rotation, then number 2 image will become number 3. Number 3 becomes 4. Continue the same way all the way down. And this time, we will realize our images are several elements compose a permutation group. Well, permutation group made us several different equivalence classes. Then what we are the coloring solutions looking for, it should be the equivalent class of these images. Well, under the permutation group effect, after having this concept, let's analyze actually the corresponding top 4 vertices coloring problem. It is actually looking for how many equivalent classes are there. Here, the permutation that we are considering now only consider of corresponding angles of rotation, but does not consider the flippings. And this time, how are we going to solve it? First, we take a look at the permutation. How many permutations are there? We can consider 4 different kinds of rotations. The structure's permutations have included the rotation of 0 degree. Then each image is still remained unchanged. Therefore, when there is a 0 degree of rotation, the written permutation is 1 order. There are a total of 16 1-order cycles. If I said there is a 90 degree of rotation, while rotating 90 degrees, we will realize the first image rotating 90 degree, it is. Correspondingly, 2 has transformed to 2, 3 to 4, 4 to 5. It is a 4 order of cycles. Whereas image 6, after the rotation of 90 degrees, it will become 7. Therefore, 6 and 7 construct a 2-order cycle. Similarly, 8, 9, 10, 11, and 12, 13, 14, 15. They are respectively 4-order cycles, followed by 16 1-order cycles. There's a corresponding second permutation. We use P1 to represent. Then the rotation of 180 degree has constructed another permutation corresponding to the first element. The image itself does not change. Well, corresponding to 2, it will reach 4, 3 will reach 5, whereas 6 will still serve itself 7, rotated 190 degrees remain, and continued. Similarly, we can analyze the rotation of 270 degree. We use P3 to represent. It will have the corresponding permutation representation. Let's analyze all these kind of permutations. We will realize what is an equivalent class. If any permutation can make an image rotated into another image, then these 2 images belongs to the same equivalent class. At the same time, we will realize there are several mysterious parts. Some permutations, although it was rotated from this image, but no change happened. For example, it was rotated 180 degrees for image 6. After the rotation of 180 degrees, it is still itself. No change is happened. Therefore, we will realize certain permutations. Actually, towards certain images, it owns no effect. We give this type of permutations a name, stabilizer, which shows that element K is stabled by this permutation. Corresponding to G, all this permutation on top of 1 until n. Then it will contain a subgraph, which is corresponding to all the permutations, which have no effect on element K. Then we know it as K-stabilizer class. Use ZK to represent. Take a simple example. There is a permutation group, G, which is equal to identity element E, 1 exchanged with 2, 3, 4 remained unchanged, 3 changed to 4, 1, 2 remained unchanged, and 1 exchanged with 2, 3 and 4 exchanged with each other. Then, for this basic permutation group, we can see that what are the permutations which made 1 unchanged, which is what D1 is equal to. We will realize, of course, the identity element is fixed. Corresponding to the exchange of 3 and 4, 1 and 2 remain unchanged, then 1 over here will have no changes. Therefore, for one stabilizer, it contains 2 elements. One is E, another is a 3, 4. Corresponding to 2, its stabilizer class is also E and a 3, 4. What about 3? This 3 is also E, 1, 2. This 4 and this 3 is equal. And this time we have analyzed what is K stabilizer. Let's look back to see the corresponding to this. For what is this coloring problem? We will realize it's a stabilizer contains what kind of regular pattern? Similarly, we will see the corresponding to P0, P1, P2, P3, these operations for image 1, which permutation can make it unchanged. Actually, we will realize for image 1, regardless of how we rotate it, it is still it is. Therefore, its stabilizer include P0, P1, P2, P3. All 4 elements are included, and corresponding to image 2, which will make it unchanged, only P0. The rotations of 90 degrees, 180 degrees, and 270 degrees will make change to it. Therefore, they too include 1 element, which is P0. Whereas, coincidentally, the stabilizers of 3, 4, 5 are the same to 2 stabilizer. Then, corresponding to 6 and 7, these 2 elements, what this 6 contains? It contains rotation of 0 degree and rotation 180 degrees. Therefore, it is P0 and P2. Corresponding to 6 and 7, their stabilizer is completely the same. Then at this time, we will be thinking, is there a certain relationship between all equivalent class and stabilizers? Then let's take a look at the equivalence class, and we are requesting. Actually, what is an equivalent class? After looking at this image, we will realize the equivalence classes seems like the elements will be transformed into another element and continue the same way. It seems to construct an enclosed track, whereas each track is corresponding to an equivalent class. Therefore, actually equivalent class in English, to be more vivid, it is known as orbit. Corresponding to an equivalent class, it is just like a track which passed through permutation. Then the corresponding equivalent class, which is corresponding to 1, 2, 3 until n number k in n. If the existence of any permutation had caused k is transformed into L, then k and L belongs to the same equivalent class. According to K corresponding equivalent class, we will use EK to represent. Now let's look at this equation. Corresponding to the coloring of 4 vertices, what does E1 contain? E1 is who it is, which is an element. Then what about the corresponding E2? We will realize 2, 3, 4, 5. These 4 images are positioned over a track. Therefore, they are belong to the same equivalent class. Therefore, 6 and 7 can be achieved through permutation. Therefore, 6 and 7 belong to the same equivalent class. Then E6 is equal to E7. In total, there are 2 elements. And at the same time, we will realize there is an amazing part. How many permutations are there? In total, there are 4. Whereas corresponding to 1, this element, its equivalent class, contains only 1, which is the number of E1 is equal to 1. How about the stabilizers? How many are there in E1? Z1, exactly 4. Corresponding to 2, 3, 4, 5 is over the same track. There is total of 4 elements, which means E2, its corresponding number is 4. Whereas, how many stabilizers does it contain? There is 1. Look again, 6 and 7. 6, 7 belongs to the same equivalent class. Then the number of E6 is equal to 2. Whereas corresponding stabilizer, how many elements are there? 2. 2 multiplied by 2 is still 4. And this time in the unseen world, there exists a certain relationship. We will realize if there are any possibility the number of EK times the number of ZK is equal to the number of permutations.